Lesson 60, Proportionality Theorems. So when we have a triangle, we'll call it XYZ. If there is a line drawn through the triangle parallel to the base, so these two will be parallel, then it divides the triangle sides proportionally, and we can say that XA over AY equals XB over BZ. This is called the triangle proportionality theorem. The converse is also true. And the converse is if XA over AY equals XB over BZ, then the lines are parallel. Then line AB is parallel to YZ. Okay, thank you. So there's two of them. Two of the problems. So these sides will be proportional. So let's, I have a couple of examples here. So we're going to draw a triangle. ABC. And we have DE parallel to AB. This one's 3y, this one's 6, that one's 4, and that's y plus 1. So if we want to solve for y, we just set up a proportion with the sides. So 4 over y plus 1 equals 6 over 3y. Cross multiply, and we get 12y equals 6y plus 6. Subtract 6y from both sides, and we get 6y equals 6, so y equals 1. And then an example, let's do one where we have to tell if the sides are parallel or not. So is ST parallel to PR? So this is 3, that's 8, this is 4.5, and this is 12. Oh, I can already see that it is. So we set up a proportion, 8 is to 3, as 12 is to 4.5. Cross multiply. And this is that true? So if you multiply this together, you would get 36. So yes, they are parallel. So those are two examples using that theorem, those two theorems. Now, the other theorem, there's a converse too. If you have parallel lines with transversals, more than one transversal, they'll divide the parallel lines proportionally. So let's draw some parallel lines, not necessarily the same distance apart. And then it will look more like that. Then we have two transversals. We'll call these points A, B, C, D, and these ones E, F. So you have parallel lines cut by transversals. You can say that these segments are proportional. So AC divided by CE has to equal BD over DF. So they're dividing the transversals proportionally. Oh, that's cool. The other theorem is not the converse of this. What it states is if parallel lines cut congruent segments on a transversal, then they will cut congruent segments on all transversals. Isn't that cool? So when I draw the picture, you'll see it maybe. Okay, that means that they're the same distance apart. Okay, I'll have to flip back after the lesson. So if you have, I know, parallel lines, let's make them all the same distance apart. And then we have transversals cutting through, we'll call them Z. So if UV equals VW, then XY will equal YZ. And any other transversal that you draw, it doesn't matter if it's straight up and down or slanty or whatever, the segments will be equal on that. So we won't write it out, but we are going to do a problem. No, we won't do an example because it's just basically that. Okay, that's the end of the lesson.